Next problem. Find the locus of the point whose polars with respect to the circle x square plus y square minus 4x minus 4y minus 8 equal to 0 and x square plus y square minus 2x plus 6y minus 2 equal to 0 are mutually perpendicular. Given circles x square plus y square minus 4x minus 4y minus 8 equal to 0, that is 1, and x square plus y square minus 2x plus 6y minus 2 equal to 0, that is equation number 2. Let p x1 y1 be any point on the plane such that whose polar with respect to 1 and 2 are mutually perpendicular. Right? We know that the polar of x1 y1 with respect to the point x square plus y square plus 2gx plus 2fy plus c equal to 0 is xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. So here 1 implies 2g is equal to minus 4, g is equal to minus 2, 2f is equal to minus 4, f is equal to minus 2, and c is equal to minus 8. Now the polar of p x1 y1 with respect to 1 is xx1 plus yy1, substituting the value of g minus 2 into x plus x1 minus f value minus 2 into y plus y1, then c value minus 8 equal to 0. This implies xx1 plus yy1 minus 2x minus 2x1 minus 2y minus 2y1 minus 8 equal to 0. So we are grouping x term, y term, then constant term, right? X into, so there are two terms in x into x1 minus 2, right? Similarly y term, y into y1 minus 2, right? Then without x and y, minus of 2x1 plus 2y1 plus 8 equal to 0, that is equation number 3. So 2 implies, second equation implies 2g is equal to minus 2, g is equal to minus 1, and 2f is equal to 6, f is equal to 3, and c is equal to minus 2. So now polar of p x1 y1 with respect to circle 2 is, now we are using g and f from the second equation, right? xx1 plus yy1 minus 1 into x plus x1 plus 3 into y plus y1 minus 2 equal to 0. So grouping like this, x term, y term, and constant term. So x into x1 minus 1 and plus y into y1 plus 3 plus minus x1 plus 3y1 minus 2 equal to 0. That is fourth equation. Given that 3 and 4 are mutually perpendicular, we know that if two lines are perpendicular, then product of their slope is minus 1. So slope of 3, let it be m1, which is equal to minus x1 minus 2 by y1 minus 2. We know slope of ax plus by plus c equal to 0 is minus a by b, right? So we are using that formula, that is equation number 5. Slope of 4 is m2, let it be m2, that is equal to minus x1 minus 1 divided by y1 plus 3, that is equation number 6. So since 3 and 4 are mutually perpendicular, so 5 into 6 equal to minus 1. So m1 m2 is equal to minus 1. So you will get minus x1 minus 2 by y1 minus 2 into minus x1 minus 1 by y1 plus 3 equal to minus 1. So just to do the cross multiplication, so numerator minus into minus plus, so x1 minus 2, x1 minus 1, right? x1 minus 2 into x1 minus 1, which is equal to minus 1 into y1 minus 2 into y1 plus 3, that is the denominator. So taking all the terms together to left hand side, x1 minus 2 into x1 minus 1 plus y1 minus 2 into y1 plus 3. So simplifying x1 square, multiplying each and every term, then plus 2 minus 2x1 minus x1 plus y1 square minus 6 minus 2y1 plus 3y1 equal to 0. Simplifying, you will get x1 square plus y1 square minus 3x1 plus y1 minus 4 equal to 0. Hence the locus of p x1 y1 is x square plus y square minus 3x plus y minus 4 equal to 0. Next we are going to see inverse point. So definition, let x square plus y square plus 2gx plus 2fy plus c equal to 0 be the circle with center c and radius r. 2 points p and q are inverse points with respect to the given circle if c, p, q are collinear such that p and q are in the same side of c and cp into cq, which is equal to r square, right? So the center of the circle, then the point P and Q are collinear, are in the same line. P and Q are same side, either left side or right side of the center, right? Then the distance CP and the distance into the distance CQ, which is equal to the radius square, right? R square. If 2 points P and Q are inverse points, then first point CPQ are collinear, second point CP into CQ is equal to R square. So CP is any point, Q is another point, then they are like this, right? So then they are collinear. Let C be the center and R be the radius of the circle x square plus y square equal to R square. 2 points P and Q are inverse point if and only if Q is the point of intersection of the polar of P with respect to the given circle and the line joining P and C. So inverse point if and only if condition, right? Q, that point Q is the point of intersection of polar with respect to the given circle, polar of P, and the line joining P and C in between, right? Like this. We'll see the proof. Given circle is x square plus y square minus r square equal to 1. Suppose P and Q are inverse point. Let the coordinates are P x1 y1 and Q x2 y2. Since P and Q as inverse point, first CPQ are collinear, we know, and CP into CQ is equal to R square. So C is the center, because here the circle is x square plus y square equal to R square. So center is 0, 0, radius is R. So this is x-axis, this is y-axis, right? So P x1 I1 is a point and Q x2 y2 is another point. So they are collinear, they are in a straight line. So now polar of P, that is the chord, right? The mentioned in the green line, right? We know that the points x1 I1, x2 y2 and x3 y3 are collinear. Then the area of the triangle formed by these 3 points is 0, right? That is the standard result we know. So that is half x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 equal to 0. That means x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 equal to 0. So condition 1 implies all are collinear, means so x1 I1, x2 y2, 0, 0, all 3 are collinear. C, P, Q. So substituting the values, x1 into here x1 is x1 I1 is x1 I1 and x2 y2 is x2 y2, but x3 y3 is origin 0, 0. Substituting in that, so x1 into y2 minus 0 plus x2 0 minus y1 plus 0 into y1 minus y2, right? So you will get x1 y2 minus x2 y1 equal to 0. That is equation number 2. Now CP, the distance, using the distance formula. C is 0, 0, P is x1 y1. Using the distance formula, we will get root of x1 minus 0 the whole square plus y1 minus 0 the whole square. So that is CP is equal to root of x1 square plus y1 square. Similarly, we are going to find, so CP square is equal to x1 square plus y1 square, squaring both sides. That is equation number 3. So similarly, we are going to find CQ. So taking C 0, 0, Q is x2 y2. So using the distance formula, root of x2 minus 0 the whole square plus y2 minus 0 the whole square. So CQ is equal to root of x2 square plus y2 square. So squaring both sides, CQ square is equal to x2 square plus y2 square. That is equation number 4. So condition 2 implies C square plus Q square is equal to R square the whole square, because CP into CQ is equal to R square. So squaring both sides, CP square into CQ square is equal to R square the whole square, that is R power 4. So using 3 and 4, we will get x1 square plus y1 square into x2 square plus y2 square is equal to R power 4. So simplifying, x1 square into x2 square, multiplying each and every term, plus x1 square y2 square plus y1 square y2 square plus y1 square x2 square equal to R power 4. So x1 square x2 square plus y1 square y2 square plus y1 square x2 square plus x1 square y2 square, which is equal to R power 4. So that is x1 square x2 square plus y1 square y2 square So these two terms, the remaining balance two terms, can be written as x1 y2 minus x2 y1 the whole square plus 2x1 x2 y1 y2, that is equal to r power 4, because a square plus b square can be written as a minus b the whole square plus 2ab, right? We are using that formula. So that is equal to x1 square x2 square plus y1 square y2 square, because from 2 x1 y2 minus x2 y1 equal to 0, right? 0 plus 2 x1 x2 y1 y2 equal to r power 4. So a remaining term can be written as a plus b whole square formula, right? x1 x2 plus y1 y2 the whole square, which is equal to r power 4. Taking square root on both sides, x1 x2 plus y1 y2 is equal to plus or minus root of r power 4, right? That is plus or minus r square. So p x1 y1 and q x2 y2 are lie on the same side of c, then x1 x2 is greater than 0, y1 y2 is greater than 0. So if it is same side, right, therefore x1 plus x2 plus y1 plus y2 greater than 0, right? Suppose if it is in the negative side, both are negative, right? Minus x1 then minus x2, similarly minus y1 minus y2 if it is on the negative side, right? If it is on the positive side, both are positive, x1 x2 y1 y2. So multiplying, you will get minus x1 minus x2 plus x1 x2 minus y1 minus y2 plus y1 y2. That is what we have mentioned. So x1 x2 plus y1 y2 equal to r square. So because it is positive, therefore we are taking positive value, because x1 x2 plus y1 y2 equal to plus r square or minus r square. So we are taking r square plus positive value. So p x1 y1 and q x2 y2 are conjugate, right? Implies q x2 y2 lies on the polar of p x1 y1. So this implies q x2 y2 is the intersection of cp and the polar of p x1 y1, right? Conversely, suppose q is the point of intersection, right, of the polar of p and the line joining the point cp. We have to prove p and q are inverse point. To prove that, first one, cpq are collinear and cp into cq is r square. Since q is the point of intersection of cp and polar of p, q lies on cp, so cpq are definitely collinear. To prove cp into cq is equal to r square, cp is equal to root of x1 square plus y1 square by using distance formula, that is equation number 5. We know that polar of p x1 y1 with respect to 1 is x1 plus y1 minus r square equal to 0, that is equation number 6. So clearly q is the point of intersection of cp and 6, right? So cq is equal to the perpendicular distance from c 0, 0 to 6, right? Therefore using the perpendicular distance formula, cq is equal to modulus minus r square by root of x1 square y1 square, right? So cq is equal to r square by root of x1 square y1 square. So cq is equal to r square by root of x1 square y1 square is cp from equation number 5. So cp into cq is equal to r square. So hence p x1 y1 and q x2 y2 are inverse point. First condition also satisfied, second condition also. The inverse point p with respect to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 is the foot of perpendicular from the center of the given circle to the polar of p, right? Thanks.